Today's lesson is on finding antiderivatives. So I'm going to start out this video just giving you all of the things to memorize, and then we'll do some examples. The nice thing is with this lesson is that you've already memorized these things for the most part. We're just going in the opposite direction. So this lesson kind of works as a nice review on some derivatives you had to memorize earlier in the year. You can probably guess what this first one is. The antiderivative of e to the x is e to the x, and we're always adding that plus c. Okay, exponential function a to the power of x is 1 over natural log of a times a to the x plus c, which is the same thing as just a to the x over ln of a plus c. And then the antiderivative of 1 over x is the natural log of the absolute value of x plus c. Now we're going to get into some trig antiderivatives. We've already talked about cosine and sine, but just a nice little repeat. Cosine is sine x plus c, and then sine is negative cosine x plus c. So here are the next ones. Do you remember what these would turn into? So let's do this one first. Secant x and tan x. The antiderivative of that is secant x plus c. And then so this one, your brain's probably thinking, oh yeah, it's cosecant. But if this is positive, the antiderivative, this is negative. Okay, do we remember these? Secant squared, that's the antiderivative, will be tan x plus c. And cosecant squared is going to be negative cotangent x plus c. Okay, so the last three that we're going to write down is just kind of a, hey, memorize these for these notes. Do these look familiar? What were we doing when we were dealing with these? This had to do with inverse trig. So this first one, so here we have the absolute value and here we don't. So this one, and when we don't have the absolute value, that's where we start with 1. But where we have the absolute value, that's when the x's were next to each other. These are just kind of little things I remember talking about, trying to help us memorize these. The first one is the inverse sine of x. The next one is the inverse of secant. And this last one is the inverse of tan. We won't be working with these as much, but it's important that you can recognize them so you don't like look at this and start trying to manipulate it and do all this algebra when you realize, oh wait, it's just tan, inverse tan. Okay, let's do some practice problems. Okay, so the first one, I've got the integral of 2x squared minus 3 over x plus 2 to the power of x dx. So we're going to find the antiderivative of each of these terms. The first term, that's power rule that we've been practicing. So let's raise this exponent up 1 and divide by that number. Okay, this one is the new one. I know it looks like you could think of it as 3x to the power of negative 1, but what happens when you raise 1 and divide by that? You would have 3x to the 0 divided by 0. That doesn't work. So this is, 3 over x. That would be minus 3. Think of that as 3 times 1 over x. So then the antiderivative would be natural log of the absolute value of x. And then exponential function plus 1 over the natural log of the base 2 times 2 to the power of x, and always plus c. All right, and there is your answer for the first one. Okay, next one, the integral of 4 over x plus 5 over x squared. So similar to the last one, I just want you to recognize this one is when we have to deal with natural log, but this one is power rule 5x to the negative 2. Okay, so this was the same as 4 times 1 over x, so the antiderivative would be 4 times the natural log of the absolute value of x. And then we need to raise your exponent up 1 and divide by that. So 5x to the power of negative 1 divided by negative 1. And then we can clean that up. We can change that to minus 5 over x. I don't know why I put plus 1. It's supposed to be plus c. Plus c. All right, next one. Here we've got 2 terms. This we can do power rule because that's just power 1. And then cosecant squared, that's going to be that negative cotangent. Okay, so for the first term, raise it up a power, divide by that power. This will turn to minus 3 cotangent x plus c. And that's it for that one. For this one, it looks complicated, but we can just do some simple algebra to simplify this down a little bit. If you're dividing by a monomial, you can just divide each term by that. So I'm just going to rewrite this first. X to the third over x plus x divided by x minus 7 over x. So then this can simplify down to x squared plus 1, and then keep this as just minus 7 over x dx. So now the antiderivative, x to the third over 3 plus x minus 7 natural log of the absolute value of x plus c. So that little step here made this a lot easier. Similar to the last one, we can just do a little simplifying first. I can distribute, but let's think about this. So this is x to the 1/2. So I'm going to just write this as x to the 1/2 times x minus x to the 1/2 times 3x to the power of negative 1. And then when you're multiplying powers of the same base, add your exponents. So 1 plus 1/2, so that's x to the power of 3 over 2, minus, this would be 3x to the power of negative 1/2. And now we can do power rule. So raise your power by 1. So that's going to go to 5/2 and then divided by 5/2. Minus, let's see, raise this power by 1. 3x to the 1/2 divided by 1/2. And then let's just change this. Dividing by a fraction is the same as multiplying by a reciprocal. So it's actually 2/5 x to the power of 5/2 minus, instead of dividing by half, multiply by 2, so that turns into 6. And then x to the 1/2 is the square root of x. And really this term could have also be rewritten as the square root of x to the 5th. But I'm going to just leave that as my final answer. But what did I forget? Plus c. Okay, final example. 5 over 1 plus x squared dx. So is there any algebra I can do for this? Or is it something you need to memorize? So this is simply 5 and then times the inverse of tan x plus c, and that is it. So there is your full video on finding antiderivatives, giving you some tips and tricks and all the things to memorize. So good luck.